Hi, welcome to another video. Today we are going to talk about Quorum. And what is Quorum? It's a voting mechanism for distributed systems. So let's get into it. So what is a problem with the replication? One of the problems that can arise is split brain. So it is great for availability, but there can be inconsistency. And especially when a network breaks, there can be a split brain problem. So split brain is a problem where there can be two different leaders for the same set of servers, and both of the leaders think they are the leaders and they are not aware of the other leader being present. And this is a common replication problem, and we will discuss about it later in depth in another video. Let's focus on this problem: successful write but stale read. So let's say there are three different set of servers or three replicas, and the write request comes to the three servers, but one of them is down. So what will happen is these two servers will now accept the latest write, but this server will not accept the latest write. So when we try to read data, and if we just read data from one server, in that case we might read it from the out of date server, and that will give us stale data. This problem is called stale read. So even though the write was successful because there were two servers that accepted the write, the read is stale because unfortunately we read from the out of date server. So in this case, Quorum can be very helpful. It can come to the rescue. So what is Quorum? Again, a Quorum is a voting system for our data. An operation is only successful if it gets a minimum number of votes or acknowledgements. What are the types of quorums? We have read quorums, write quorums, membership quorum, configuration quorum. As you can imagine, these are quorums that are applied to different scenarios. What is read quorum? We need a vote from the members of the servers when we try to read a data. Similarly, we need a voting system when we try to write the data. Membership quorum, if a server is a member of a replica set or not, that membership quorum. And configuration quorum, also the server nodes need to agree on the configuration, and in that case configuration quorum comes into the picture. But in all such scenarios, the fundamental concept remains the same, which is quorum. So let's try to understand it a bit more in detail. So let's say we have a strong consistency rule for the quorum. What is it? The W plus R greater than N. Let's try to understand it a bit more in detail. Let's say I have 5 different servers. When we try to write a particular data record, 3 of the servers need to accept them. So this 3 is our N. So N equal to 3. And now, so whenever we try to write, let's say there is a write request that is incoming. That write request needs to be replicated to some server. So let's say I replicate it to 2 servers. Then this strong consistency rule of Quorum is saying when I try to read, the read request also needs to be replicated to 2 servers. Why is that? Because this 2 and this 2 is 2 plus 2 equal to 4, which is greater than 3. What is it ensuring really? As you can see, if the W plus R is greater than N, there is at least one node in the set where the data is the latest. And that's what we guarantee using the strong consistency rule. You can see that individually read and writes are not that slow, because the write does not need to wait till all the 3 replicas acknowledge the request. It only waits for only 2. And similarly, read request is only needs to be acknowledged by 2 of the servers. But whenever we write and whenever we read, if we always maintain that we need a vote of consensus between, we need a quorum from 2 of the servers, then we always make sure that we read the most up-to-date data. Also, there is another rule that we can follow, which is the majority write rule. In that case, W is greater than N by 2. The write quorum must be a strict majority. So this is the antidote to split brain. By requiring a majority, it is mathematically impossible for 2 isolated groups to both accept a write. So let's say again there are 3 servers, and if we make sure that W is equal to 2, in that case, whenever only 2 servers accept a request, we can say the write is successful, because it is impossible for the other server, which is, let's say, out of date, it is impossible for it to gain a majority, and this would never win. So only the partition with the majority of nodes can make progress. Now, of course, you can see that we can tune our quorums. Again, let me draw 3 servers, and then we make a read request, and we can also make a write request. So let's say n equal to 3, w equal to 3, r equal to 1. Each of the writes need to be accepted or need to be acknowledged by all the 3 replicas, but the read request needs to be acknowledged by only one. Let me actually try to write that. So this is a write request. Write request needs to be acknowledged by all 3, but the read request has to be acknowledged by only one. In that case, the write requests are slow, but the read requests are fast. Why? Because the write request needs to be acknowledged by all the 3 servers, and of course it will take time due to network delay or something else. Whereas the read request needs to be acknowledged by only one. Because the write is acknowledged by all of the replicas, we always make sure that all the replicas are up to date, so we can read from any of them. So of course you can imagine the reads are quick, but writes are slower. For example, a newsfeed application may not have to write to our database very often, but there can be a lot of read requests. There can be millions of readers who can read the data from the newsfeed. So of course we need to prioritize fast read. So in that case, we will accept write being a bit slow if we have a faster read. Similarly, we can optimize for fast writes as well. For example, bank transaction. In bank transactions, there can be a lot of customers and there will be a lot of transactions going on in a day. In that case, the writes need to be relatively faster. So we can go with w equal to 2, r equal to 2, and n equal to 3. As you can see, the write does not need to wait for all the 3 replicas. So it is relatively faster, and read is also relatively decent because we don't have to wait for acknowledgement from all 3. Let's learn a bit about Quorum in the wild, where quorums are used in real world scenario. So Amazon DynamoDB, Apache Cassandra have tunable consistency levels. We need to understand the Raft and Paxos. These are different algorithms that are used for quorums, for leader election and log replication. We can understand them in a later video. So what are the key takeaways from the video? Quorum is a voting mechanism to ensure data consistency in our distributed system. The majority write rule, it prevents split brain, and the consistency rule ensures that you read the latest data from at least one copy of the server. And we can always tune the quorum settings, and these settings are trade-offs between read performance, write performance, and consistency. So that's it for now. Hopefully you like the video and the content of the video is useful to you. If you like the video, please hit the like button and subscribe to my channel and share this video among your friends. Thanks for watching. I'll see you in the next one.